Hi, it's Sean from Tested, and today we have a very special guest, Alonso Martinez, in from Pixar, and he's brought his family.
Yes.
So Alonso,
I work at Pixar, but these are separate from the Pixar.
So just because people are going to know, what do you do for Pixar?
So I help make the characters that you see up in the movies, and what that means is like, imagine that first we make the clay sculptures, and then I have to do all the puppeteering to kind of like make them move.
But you're doing the clay sculptures, you're doing it digitally.
Yes, exactly.
Right.
That's right.
And then you're basically putting in the skeleton and making them move to pass on to the animators.
Yep.
Okay. So this is a little different.
Yes.
What do we have? Well, tell us about your family.
Yeah. These are a little family of robots that it's just basically me exploring that same idea about in movies we bring characters to life, and it's about how do I do the same thing but make them more interactive, and so that people can, unlike movies where you see really amazing things happening, but you actually can't interact with them. So what would it be like if you could interact with characters?
So today we're going to talk about Mira. So tell us her story.
Yeah. So it kind of begins with the first robot, which was it began with Gertie.
Yep.
And Gertie was, I came from an animation school, and the very first test you do in animation school is a ball bounce. And so this robot jumps around. And then I found myself spending a lot of time thinking about how it moves. And that's not necessarily what I was interested in. It was more the personality. And so I was trying to think of a robot that was the least complex, but still carried that kind of like, like personality and that people would kind of relate to it. And so that's how this came about.
Mira. So tell us about what Mira can do.
Yeah. So Mira is a little robot that can rotate her head around, and she can play peekaboo, which I can actually, let's see if I can just show you. Hey, Mira. So if I hide, and then I go, boo.
How is she doing that?
So she does face tracking. So when I move, she's following me around, and so big shout out to the people that helped me build this. Aaron Nathan, who did the computer vision and a lot of the guts of the programming, and Vijay Sundram, who made this robot possible. But yeah, it's a really cool project.
So are her eyes actually what's actually tracking the movement? How does that work?
So this one is the V2, which has the little blinking eyes. I don't know if you guys can see that, but
we'll get a close-up.
Yeah. So obviously this little dot up here is the one that is actually doing. So you can also go, bang, bang, and then you can also go when you get really close. And so this little dot is the camera, and it's figuring out where people's faces are, and following them, and so the game of peekaboo has to do with, understanding where people's faces are.
Okay.
Yeah.
So and the shape of Mira is so simple.
Yeah.
But then she has so much character.
Yeah.
So did you find your background and experience like as an animator and from Pixar like fed right into this?
Yeah, what I was trying to do was there's this kind of design philosophy of putting what you want people to project themselves onto the character, and it's funny because like R2-D2, he might be doing beeps and boops, but you're reading into what he's saying, and that's always more truthful than if he was speaking English and was, that's why I love R2 more than 3CPO. And so with this design, I think it really allows you to project yourself and be like, is it sad? Is it mad? Is it happy? With very small kind of like little design cues.
Yeah. And do you have like your own personal backstory for Mira? Like as far as like what drives her personality or how she reacts to the environment?
Yeah, so her design is meant to be evoke kind of a baby robot, and so she's egg-shaped, like this, kind of like a sign of like a newborn baby. And other than that, yes, I think I was looking at the type of games that people play with their kids.
Right.
Before they're vocal, before they have language. And one of those games is the persistence of object persistence. And to kids, when an object disappears, it's literally gone. It's like disappeared from this world. And when it comes back, it's like surprising. So I wanted to play with those same mechanisms. And I'm really interested by the non-verbal things that, like for example, you know that game when you're playing with your dog and you like stare deeply into his eyes and then you go like that and the dog's like, oh my God.
Yeah.
So those types of unspoken games, I just love.
Yeah.
Yeah.
That's amazing. There's this little person, it just exudes so much character.
Yeah.
Like it's amazing. Not to ruin the mystique or whatever, but I would love to talk about a little bit how you made Mira. So it looks like you got, as a 3D printer, I'm seeing 3D printing here.
Yeah.
But I'm also looking at this dome is beautifully smooth.
Yeah.
So how's the body constructed?
Yeah, so it was 3D printed, and then I was talking to Adam about different methods for sanding plastic, and the big issue is that all of them, because this is a low melt temperature material.
Because you're using a filament desktop printer.
Yeah.
So like PLA?
That's correct.
Okay.
PLA, yeah. So when you're kind of sanding it, it heats up and it starts melting. The only thing that I found that works is the orbital sander, which is fantastic for kind of these concave
because this is beautifully smooth.
Yeah. And the orbital sander works fantastic for this. Now, later we will talk about the mold making process for this, which to make this shape, you actually need the inverse of it.
It's a whole other game.
Yeah, and so that you couldn't do with the orbital sanding, and it just took a lot of elbow grease.
Right.
Yeah.
So I would love to take a peek inside Mira.
Yeah,
if that's because I want to see how this works.
Yeah, sure.
So you have gutted Mira 1, Mira 2. Don't look. So this is what's in there, right?
Yeah.
So
yeah.
This is my first impression. Mira is so beautiful and simple. Like there's a lot going on in here.
Yeah.
So why don't you walk us through?
Yeah. So this all started from, and you know this, but the viewers might not. I come from an art background, and a lot of this is not something that I learned in school. And so it was literally just figuring out one thing at a time, is making the motors move, good. Like making the NeoPixel work, good. Making the speaker work, good. And then starting to get these things to work in unison. And then where I got the idea for this mechanism, which basically the head can rotate in yaw, pitch, and roll. So that's 3 different kind of axes of rotation. And where I got the idea from, just like kind of the other robots, very, very similar, I was just trying to think of what things in the day-to-day life kind of do the thing that I needed to.
Right.
And the thing that did this was from when I was a kid. I remember playing the video game Descent Free Space.
I played that a ton.
Yep.
Yeah.
And I had a joystick that was the Microsoft Sidewinder Pro.
Yeah.
And so that one had force feedback, and it had 3 axes of rotation. And so that meant that there was the 3 things that I needed, and there was motors in line with them.
Right.
And so I actually bought another one. I found it on eBay. I bought another one, and I just took it apart and was like, how is it doing what it does? And the interesting thing was that for the Sidewinder Pro, there was the entire main shaft was rotating on this little cup. And it was actually limiting the range of motion that it could turn. And here, I actually have a floating pivot as opposed to that little cup thing.
Yeah.
And it actually allows you to go much greater kind of range of motion.
And once again, you 3D printed all of this stuff.
Yes.
So
yeah.
that's it. And what are you designing this stuff in? I assume CAD.
No. So it's because I'm so used to the software Maya.
Oh yes, I'm well familiar. Yeah.
Yes.
Okay. You're doing exactly what I'm doing then.
Yeah.
You're doing
we're both doing the wrong thing, probably.
Hey, but it's the tools we know. You do what
Yeah,
you know.
it's true. And you and I were talking about how it's actually really good for one thing that these kind of robots, sometimes they have very organic shapes.
Right.
And that's really hard to do in CAD.
Yeah. So, and you can make the tools that you have at your disposal work for you. It just, good.
Absolutely.
So what else is, so are you running off, looks like a Raspberry Pi?
That's right, yeah.
Okay.
Yeah.
And you got some crazy small servos. Like I've used some small servos, but these are really, really tiny.
Yeah, so these are Power HD DSM-44s. And they're actually metal geared servos, which is really good so that they don't strip.
So they can take a lot more torque.
Right.
Okay.
Right. Yeah. And then a couple of more of the chips that there's a voltage regulator here, there's a sound amplifier here, and then there's a teensy. So there's actually two microprocessors. There's the Raspberry Pi that's handling the computer vision, which is recognizing the faces. And then there's the teensy, which is basically like a really beefy Arduino.
Yeah.
And it's actually doing a couple more things.
So, and then I see you have this ribbon. So you got the face sensor.
Yeah.
So is that just a regular camera that you're using specific software for the face recognition?
Yeah. So it's leveraging off of OpenCV, which allows you to do computer vision.
Got it.
Yep.
Now I'm also noticing, I notice these little like kind of pads in here. So that give you a smooth running surface?
Yeah, this is something that Aaron, my friend Aaron pointed out, which is basically when you have different materials have different properties, and PLA has this thing called striction, which is basically, it's actually hard to get it moving. So if two parts are touching, it's hard to get it moving, but once you get it moving, then it's free. And so that's called striction, and smooth PLA on smooth PLA was making it stick.
So it would kind of be jerky.
And so it'd be like tuck, 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 tuck.
Which is just creepy then.
Yeah, exactly. And so I actually put like a little bit of lining of Teflon.
Oh, that's great.
Yeah.
That's a
Teflon tape.
Great solution. So, this is amazing, and I love the 3D printed parts and even the framework that you did.
Oh. Yeah.
Version 1 of the Mira does not have the blinking eyes, and the eyes, the blinking just brings it up to a whole nother level. How are you doing this?
Yeah. So obviously, when you're looking into the characters, when we look at each other, the eyes are what you're looking at. And so that needs to be really high quality, and that makes you have that believability that the character is alive. And so I wanted to do something a little special. And it was quite a challenge because, so this white part is spinning around the base, the sphere, and the amount of thickness in between the sphere and the head is really.
There's not clearance.
I mean, so there's two separate OLED screens with an acrylic hemisphere kind of on top of them.
Okay.
And I was literally working for every fraction of a millimeter inside of that space, so much so that not only did I, after soldering kind of all the joints and doing the flush cutting, I actually sanded the solder points just so that it was like perfectly flush. And I used some a ribbon cable that is like, I think it's something like 32 connections per like inch or something. It's like
and you have
really
to hand solder that,
yes.
didn't you?
Yeah.
And I know, so in the little acrylic domes almost kind of magnify everything a little bit.
Yeah, right. It does this magical thing that I couldn't have asked for. which maybe in the close-ups you'll get to see the detail, but it has this kind of like looking into a galaxy feeling where it has like greens and blues.
It's beautiful.
And purples.
Yeah.
Yeah.
Well, Mira is absolutely amazing, and the amount of character that you've managed to get into this little thing is just incredible.
Yeah.
So I would like to hear, I think we should talk about some of the other ones.
Yeah, absolutely. Yeah.
Okay, Alonso. This is your first robot.
Yeah, this is Gertie.
So let's hear about Gertie.
Yeah, so in animation school, the first kind of test that you do is a ball bounce.
Oh, yeah, I remember doing many of those.
Yeah, and so I was like, I'm gonna do the same thing that I did for animation. It'll be just as easy as animating a ball bounce. Turns out I was horribly wrong, and this is like the worst first project robot that I could make. And but it kind of, I mean, it led me to learn a lot. And one thing that I didn't figure out until much later is to put the off switch in a very accessible place.
Yeah, that's always good.
And so what it does is you can kind of control, you can make it jump. And so you can actually, using this Wiimote, you can actually.
Oh, so it's got motion controls and, oh my God.
Yeah. And so you can actually kind of steer it in different directions and make it jump. And so when you press this button, you can actually control it the down and then the up. Yeah. And then you can make it do a little dance.
So kind of Mira's like expression and Gertie's like movement, and so it's like the different like studies.
Exactly. Yeah.
Oh my God. So okay, this is amazing. Now Gertie has this like nice squishy exterior. How'd you do this?
Yeah. So just to be able to achieve the same thing that you get with a ball is
the
called
squash and stretch.
The squash and stretch, right?
Yeah.
One of the 12 principles of animation. And so I was like, let's learn how to do mold making, and
like that.
And it's awesome because normally with molds, like say that you're making a gun prop or some sort of a prop,
which we've done tons of on testing.
Exactly.
Yes.
So it's usually the part is hard, and then so the mold has to be soft. But here we're printing soft parts, so you can actually have the mold be the hard part. And luckily, we have 3D printers to do that.
Amazing.
And so, for example, this is the feather, and it's a two-part mold that is bolted together, and then there's a little 100cc syringe that you're injecting it with, and then you wait an hour, and then you get like awesome, like super stretchy,
God.
yeah.
Now, so this is obviously you're printing this on your filament printer, and you're basically doing injection molding for silicone.
Yeah.
Okay, let's talk about this. So now I'm noticing this is the facing surface of this. This is like glass smooth. All right. So how torturous was that?
Yeah, a lot of elbow grease, and especially because. I'm hand sanding this. I did not hand sand this one, like we said with the orbital sander.
Right.
This one I had to hand sand for kind of multiple different reasons. But one of the things that if you're using any power tools is that the edge that is separating the top and the bottom part of the mold, if you're using a power tool, you're just gonna blow past that edge. And then when you cast it,
you're
gonna see a really nasty edge, and so I didn't want to do that.
Okay.
Yeah.
And are you just using we use smooth on stuff like a ton? Is this just like regular old smooth on stuff?
So there's platinum silicone is what the great properties about it is its stretchiness, so it won't tear. Another one is that it's clear, and so you can put whatever pigment you want on it, which is super cool.
Okay.
And then it's thermally incredibly resistant. I actually, for the Ultimaker, I actually changed my nozzle using silicone.
Grip pad.
Right. I know.
Okay, so what about the body? This is like a much more complicated.
Yeah, so actually
mold.
let's show kind of how this came from this. So let's invert it and reveal the anatomy.
Look away. I can't.
It's just getting Just to change.
Oh my gosh! So there's once again there's. I love your simple forms, and then there's like there's a lot more going on.
Yeah, absolutely. And
you need to grab anything you get.
Yeah, let me see. There we go.
It's giving birth to a robot. Yes.
And so this little mushroom-looking guy. So this is still fun.
Oh yeah.
So this little robot is the Delta robot, and let me kind of turn it on again so people can see how it moves.
Oh yeah, for us, all our 3D printing people out there, you got the Delta 3D printers, kind of that 3-arm system.
Right. That's right. Yes, that's right. It's the same mechanism, and so you have left, right, and then up, down. Yeah. And then there's the feet that I can actually put on. Do you want me to go get the feet?
No, that's okay.
So that we can.
I don't even how. So how many iterations did you go? Now, part of the advantage of 3D printing is you can easily go through a lot of different prototypes. So did you find yourself doing that a lot? Like, nope, just like printing out all these little things and going crazy?
What I love is just, it's this thing that with robot, people think that you need to use metal. But I mean, this thing is getting banged on, and it's fine. And so one of the great processes about 3D printing is as soon as it would break, I would just make it a little bit thicker, and then by the end, it's super rock solid. And now this one hasn't broken in a really long time.
And once again, you're just using PLA for all this stuff, right?
Yeah.
And okay, so now I notice we have these really cool little tie rods.
Yeah.
So at what point did you decide, like, I need to go a little bit, like, actually use some hardware versus the 3D printed, or?
Yeah, so I tried making my own, but it didn't quite work out, and just using, oh, Mira, you're looking at us? Oh, you're looking at your brother?
What have you done to Gertie?
I know. Yeah, so I just found these tie rods that were for RC cars.
Yep.
And they worked out great.
That's very cool.
And it has this kind of beautiful blue anodized with the red anodized motors, which looks really nice.
You can do like the bear skin, like menacing one.
Yes.
So, okay, and then with this particular mold, you have this little bit more complex one for the skin, because you actually did an actual core.
Yeah.
So that allowed you to do like the little lips and stuff inside.
Exactly. Yeah. Right? It says a 3-part mold, and we can kind of pop it on this guy. Yeah. Right. It's funny because I can actually see sun damage.
Oh yeah.
Because in my house it's actually by the window. Thank you, sir. Get in there. Okay, and then that's not quite what it looked like.
Get the idea. Yeah.
Yeah.
It's
funny?
It's okay. It's okay.
That's what I'm doing to your brother. Funny to you.
And then once again, a lot of sanding. I'm thinking here too.
Exactly. Yeah. So this mold came out of here, and then obviously not with the feather.
Right.
So it won't quite fit the right way because it has the feather in here. But then these kind of 2 parts hug it.
Just screw it together?
Yep.
Are you using injection molding on that too, like the syringe, like?
Exactly. Yeah. Okay. So actually, no. Sorry. In future designs, I did that.
Okay.
But with this one, it was actually just gravity fed. It just had a really large opening, and I was doing that trick to pop the air bubbles.
Yeah.
So I have a vacuum degasser.
Yep.
Which when you mix the part A and the part B, the 2 materials are really like sticky and thick.
Yeah.
And when you're mixing it, you're putting all these air bubbles in there. And so the vacuum chamber basically makes all those bubbles pop.
Right.
And then another one of the tricks for mold making, as I'm sure you guys have talked about, is if you pour it from up high, the string will get so thin that it'll stretch all those bubbles and then it will pop them.
Yep.
And so I just sat there for like 15 minutes, like holding my arm up, like trying to like.
Great. This is just amazing. And then this is just you just hack this together too. Did you?
Yeah.
Now a lot of the stuff, the components you're getting, is this like off the shelf stuff, or did you have to like do a lot of custom stuff, or can you kind of find what you need and just kind of make it work together?
So I mean, there's some code written for the nunchuck, and then basically all I did was made a battery operated as well as hook up the wireless component. For Gertie, I'm using this wireless chip called, it's like really long, it's like NRF, like 4L01 or something like that. But one of the other components that I had to make is for Gertie, you know, I knew that I wanted it to have its own springs so that way when it was standing up on its own, I could push it down kind of without it wanting to.
Okay.
And so I knew that I was going to need springs. But
So they're up here at the top of the arms.
Yeah,
right?
exactly.
Okay.
I knew that I needed springs, but I didn't know. I mean, there's so many properties. There's so many like numbers about springs, and I really didn't know what I needed.
Was it one of those cases where you knew in your head what you needed?
Yeah.
But then you're like, what do they call that? I don't know.
Yeah.
Right.
And like, what is the right number? And I'm sure there's like a correct mathematical. There is a correct mathematical equation, but instead I bought music wire, and I 3D printed this little jig that I could wind.
You made your own springs?
Yeah. Yeah.
So is this one of them?
Yeah, this is one of them.
Oh my God.
Yeah.
That is amazing. So you would just sit there like try one like almost, and then just keep going.
Yeah. So I just got a bunch of different thickness wires, and then this.
Oh man, those are
Oh, that's beefy. Yeah.
Yeah.
That's for I made that's actually for the version of this one that is it can jump a human.
What?
So yeah, so that's why the springs are so much stiffer.
Well, that makes sense. Okay. Alonso, thank you so much for bringing your family in and sharing this with us. We'd love you to come back again when you're done with the newest one and show that. So you said you need to do more casting and everything. So Alonso, we'll have links in the bottom that you can find Alonso's stuff. And we really thank you for coming in and visiting.
It's my pleasure.
It's Sean from Tested, and thanks for tuning in.
See ya.